Imagine this, tomorrow, now Europe faces a major military conflict. Fighter jets are ready, the destroyers leave port, missile batteries stand by, thousands of tanks wait for orders. Then something unexpected happens. The fuel stops coming. No fuel means no fighter sorties, no naval operations, no logistics, no missiles reaching the front line. Modern militaries don't run on courage. They run on energy. And after recent tensions around the Strait of Hormuz and attacks on commercial shipping in the Red Sea, one question has become impossible to ignore. What happens if Europe can no longer import enough fuel during a war? Can Europe actually manufacture its own military fuel using nothing but electricity, water, and carbon dioxide? It sounds like science fiction, but the technology already exists. Today, we're exploring how synthetic e-fuels could become Europe's ultimate strategic asset, and why the battlefield of the future might be powered by thin air. For over 100 years, global military dominance has been tied to crude oil. Oil is an incredible energy source. Nature spent millions of years creating it. Ancient plants and marine organisms died, were buried, and over geological time, intense heat and pressure transformed them into crude oil. Humanity simply drilled into the ground and extracted an energy source that nature had already refined. And it was astonishingly cheap. A single barrel of oil contains roughly the energy equivalent of several years of continuous human labor. No civilization in history had access to energy this concentrated. Cheap energy built the modern world. It powered industrialization, commercial aviation, global shipping, and modern warfare. According to an analysis by MIT's multi-sectoral impact study, while the global power sector has successfully cut carbon emissions by roughly 40% since 2005, transportation emissions have remained largely flat. Why? Because density matters. Batteries work for local cars, but heavy armor and jet fighters demand extreme energy density that only liquid fuels can provide. Military historians often say amateur stock strategy, professional stock logistics. During World War II, Germany possessed some of the world's most advanced tanks. Yet one of the Axis power's greatest strategic failures was its inability to secure foreign oil fields in Romania, the Caucasus, and North Africa. Without fuel, even the most advanced weapons become expensive paperweights. The same is true today. A modern fighter jet burns several tons of fuel during a single mission. A guided missile destroyer consumes tens of thousands of gallons daily at sea. And an armored division requires thousands of liters of fuel every single hour during combat operations. The military doesn't simply need weapons, it needs an uninterrupted river of fuel. In fact, the 2023 U.S. Department of Defense Operational Energy Strategy highlights a major doctrine shift toward what they call energy visibility. Military planners are no longer just looking at how many shells or missiles they have. They are now using real-time data to calculate the exact energy cost and supply chain risk of a mission before a single vehicle even moves. This brings us to Europe's current reality. Europe imports the vast majority of its crude oil. Much of this energy passes through vulnerable maritime choke points. The most famous is the Strait of Hormuz, where roughly 1/5 of global oil consumption squeezes through a narrow waterway every single day. Recent regional conflicts have shown how easily commercial maritime shipping can be disrupted by low-cost sea drones, long-range anti-ship missiles, and satellite-guided tracking. Even if fuel is shipped safely across the Atlantic from North America, every single tanker entering European waters becomes a high-value target. And the problem runs deeper than crude oil. A recent European Parliament briefing on energy security warned that European defense is facing a dangerous refining bottleneck. Europe isn't just dependent on importing crude, it's losing the domestic refining capacity needed to turn that crude into usable military-grade jet fuel and diesel. The briefing drew a stark parallel. Europe's fuel supply chain risks are now mirror images of its high-tech defense risks. Just as a shortage of rare earth elements can stop missile production, the famous no minerals, no missiles dilemma, a choke point at sea, or a hit to an aging refinery can freeze the entire military grid. What if Europe could bypass the ocean entirely and manufacture its fuel domestically? This is where chemistry gets incredible. Synthetic fuel, or e-fuel, doesn't require drilling. It relies on three basic inputs: water, carbon dioxide, and energy. Step 1. Hydrogen extraction. Electricity is used in a process called electrolysis to split water into oxygen and hydrogen. When powered by renewable energy or nuclear power, this yields clean, green hydrogen. Step 2. Carbon capture. Instead of drilling underground for carbon, CO2 is captured directly from industrial smokestacks or right out of the ambient air using direct air capture. Step 3. Synthesis. Using the Fischer-Tropsch process, scientists react hydrogen with carbon monoxide derived from the captured CO2 to forge synthetic hydrocarbon chains. Research from the DLR Institute, the German Aerospace Center, confirms that these Fischer-Tropsch fuels are already certified as drop-in components. They can be blended up to 50% with conventional Jet A1 fuel right now, requiring zero modifications to existing aircraft engines or fueling infrastructure. And here's where it gets even better. E-fuels aren't just replacements, they are designer fuels. Because they are created in a clean laboratory environment, they lack the impurities, sulfur, and heavy aromatics found in crude oil. The DLR Institute notes that e-fuels can be chemically engineered to increase their net heat of combustion, giving a jet engine more energy per kilogram, while drastically reducing soot emissions. Fewer soot particles mean a lower thermal and visual signature for stealth aircraft, while simultaneously reducing engine wear. Beyond the Air Force, this energy transformation changes tactics on the ground. The 2023 DoD Operational Energy Strategy highlights that integrating synthetic fuels alongside hybrid tactical vehicles unlocks a critical combat advantage, silent watch. Hybrid armored vehicles running on high-density synthetic power can turn off their main engines and operate silently on forward bases with drastically reduced acoustic and thermal signatures, making them virtually invisible to enemy infrared sensors. Furthermore, research from the Paul Scherrer Institute highlights an alternative process known as sun-to-liquid technology. Instead of converting solar energy into electricity first, which causes efficiency losses, concentrated solar towers use extreme thermal heat, reaching up to 500 degrees Celsius, to drive the chemical reaction directly. To solve the carbon problem, researchers suggest an ingenious industrial synergy, pairing e-fuel plants directly with cement factories. Since cement production releases massive amounts of CO2, fuel facilities can recycle that industrial waste, turning localized pollution directly into high-performance jet fuel. Of course, if this were easy, it would already be done everywhere. Synthetic fuels face massive hurdles. First, the price tag. Techno-economic analysis from the DLR Institute reveals that synthetic liquid fuels currently cost roughly 4 times more than conventional fossil fuels. Second, land and scale. A study by the Paul Scherrer Institute calculated that powering a pure solar thermochemical plant capable of producing meaningful strategic volumes would require a staggering land footprint of roughly 68 square kilometers, packed with mirrors and solar towers. And third, grid infrastructure. Replacing military oil consumption would demand gigawatts of dedicated renewable and nuclear power across Europe, alongside thousands of microgrids. As noted in the European Parliament briefing, decentralizing fuel production into hardened military microgrids makes bases immune to cyber attacks or strikes on the main power grid. But building this infrastructure requires hundreds of billions of euros. For over a century, military power has depended on who controls the oil under the ground. The future of strategic autonomy, however, may depend on who controls the technology above it. The chemistry works, the drop-in compatibility is proven, the tactical advantages are real. The real question isn't whether Europe can manufacture synthetic military fuel out of electricity, water, and air. It's whether Europe can scale the infrastructure before the next major geopolitical crisis forces its hand. Because in modern warfare, victory isn't just about who has the best weapons. It's about who can keep those weapons running when the rest of the world shuts down. If you enjoyed this deep dive into defense technology and geopolitics, hit the like button and subscribe for more breakdown videos on the technologies reshaping global security. See you in the next one.